Hello, I'm Suryana. Previously, the presenter have included the introduction in their talk in Seminar Talk 2.
This is our group members.
Due to the previously taught for the Seminar 2 from the TNB lab, we can learn what is transformer. Theoretically, transformer can be said as transfer electrical energy from one circuit to another through inductively coupled electrical conductors. However, in reality, transformer is more than simple electromagnetic device. It has complex equipment with many functional components, as you can see the figure above. So, here are transformer in electrical network. There are three main parts in electrical power system network, which are generation systems, transmission system, and distribution system. As you can see, the electrical power system there. Distribution system are the link from the distribution substation to the customer, which consists of transformer, feeder circuit, switch, protective equipment, primary circuits, secondary circuits, and service line. Distribution feeder circuits usually consist of overhead and underground circuits in a mix of branching laterals from the station to the various customers. The circuit was designed by considering the required peak load voltage distance to customer and other local conditions such as terrain, visual regulations, or customer requirements. In distributions, there are two types of the system that have been used, that is overhead lines and underground cables. High density urban areas are often connected in a complex distribution underground network, providing a highly redundant and reliable means connecting to customers. Here are the main part of transformer in electrical network, which is current transformer, voltage transformer, circuit breaker or switchgear, and lastly disconnector. That's all from me, Suryana.
Hello, I'm Annabel, and last week's talk shows the application of transformer. For the first application, onboard traction transformer are used for power supply of railway electric vehicles from the catenary system, such as high-speed train. Next, at the oil rig, so cast resin transformer and sub-transformer are used for the power supply at the oil rig. For the industry, furnace transformers are widely used at the industry for power supply. Moreover, the power supply used at the generation plant are cast resin, hermetically sealed, and generator transformer. Next, for the transmission, hermetically sealed and transmission transformer are used as the power supply. Lastly, for the distribution, we have pole-mounted, cast resin, and hermetically sealed. So pole-mounted are widely used at the rural area, and most of the Sabah and Sarawak are still using pole-mounted as their power supply. And that's all from me. Thank you.
Importance of transformers. Why transformer is very important? The first important is failure power interruption. If these transformers break, electricity production to consumer may be disrupted. For the second point is the highest capital investment. A transformer is one the most expensive purchase. To put it another way, transformers are among the most costly item in which we must invest our resource. Like example, obtaining transformers is a lengthy procedure. We frequently have to order massive transformers from outside the country. For the third important is safety pupil equipment. In terms of safety, transformers are pretty crucial. It affects not just the transformers themselves, but also the person who work with or near them. The breakdown of the transformers will not only result in a trip, but it will also endanger the public and those who live near the transformers. For the last important is a critical asset in electrical network. Transformers are one of the essential components of the electrical grid. Transformers are the most critical equipment in terms of generating, transmission, and distribution network equipment. If it does not operate, we will not get electricity from the power plant to the consumer.
Power transformer insulating system consists of two primary components, which is oil insulation and paper insulation. Function of insulation system. First, oil insulation. Oil insulation provides sufficient cooling to dissipate the heat loss, provide sufficient dielectric strength that to separate different potential parts and improve efficiency of the paper insulation. Preserve the core and coil assembly by filling void in the insulating materials and minimize contact of oxygen with cellulose and other materials that are at risk for oxidation. Next, paper insulation. It acts as a dielectric by storing electrical charge when the transformer is energized. Isolate transformer components that exist at different voltage and fulfill a mechanical function by supporting the windings and contribute to better thermal health of the transformer by creating cooling duct for the coil. The advantage and limitation of insulation system. For the advantage, it provides high mechanical strength, flexibility, and low cost. For the limitation of insulation system, it are inferior dielectric strength, low thermal conductivity due to air-filled gaps between fiber, and high gross capacity due to the developed surface of fiber that can readily absorb moisture penetrating into pores.
Condition monitoring of transformer. Condition monitoring of transformer, known as condition-based maintenance. Majority of failures does not occur instantaneously but develop over a period of time. Activities are designed to identify a specific characteristic change that is indicative of a future failure. Two-step processes. Number 1. Monitor any significant change in parameters. Number 2. Initiate a maintenance task when a change is detected. The objective is to monitor the condition of transformer and provide an early warning of fault. And number 2, to diagnose problem when transformer exhibit signs of distress or following the operation of protection equipment. And number 3, to determine whether a transformer is in a suitable condition to cope with unusual operation conditions. Condition monitoring in general definition. Inspection and measurement of plant parameters and the recommendation of action based on information gained from these parameters to increase the probability that the plant will continue to reliably perform in function. And lastly, this is potential area of research.